A very good morning. My name is Tainan, son of Krishnamurti. My matrix number is AD 190069. Today I'll be talking about the theory for polygon of forces. It's actually very simple. When four forces or more acts in the same plane but in different directions or stationary body, their lines of action meet at one point. Because of this, the forces can be represented by a force diagram called the polygon of forces. This diagram can be used to find the magnitude and direction of the two forces when the magnitude and direction of all other forces are unknown. In this design, pin-jointed plane structures such as girders, bridges, and roof trusses. It is needed to find the forces acting in each member so that a frame can be made strong enough to withstand the maximum load exerted upon it. The polygon of forces is usually used to find forces and deals with each joint in turn. That means at each joint, we use it to find the unknown one. This experiment could be regarded as one such joint on a structure, and it will also be shown that in a system with four or more forces, two unknowns can be found in magnitude or direction if the remaining information is known. And just to additional information, the polygon of forces is actually, if studied and investigated, it symbolizes the triangle of forces, and whereas tri means three and poly means many. So this is the theory for polygon of forces. Thank you.
Yes, my name is Inja King, matrix number AD190230. Today I'm going to talk about the procedure of our experiment, the polygon of forces. So first we got two tests, which is test A and test B for our experiment. So for test A, first we're gonna secure the mounting panel as shown in figure 2x2. This is figure 2x2. Okay. So second, we clip a sheet of paper to the board P21 and assemble with cords and weight hooks P10 as shown. After that, we add weights to give total weight as shown in figure 2x2. And we write in the white supported by each cord and noted total weight includes weight hook of 0.1 Newton. So after that, the fifth cord, which only required in test B, can be allowed to hang freely and will not affect test A result. After that, we gently cause the system to bounce by jogging the free cord and let the four cords and the weight settle freely in its equilibrium position. After that, we mark the position of the four cords with pencil dots on the paper. And lastly, we remove the paper and join out the dots representing the cords. So for test B, it's simple. First, we still keep the weight hook and the weight as shown in test A, but we attach a weight hook to the fifth cord and let it hang directly from the ring with a total weight of 1.1 Newton, including the hook. And after that, once again, we bounce the system of jogging the center weight only and allow the ring and the fifth cord and weight to settle in its new equilibrium position. After that, we mark the position of the fifth cord with pencil dots on the paper. Lastly, we remove the paper again and dry out the dots on the paper. That's all for me. Thank you.
Hello and Assalamualaikum everyone. My name is Ahmad Nabi Muhammad. My matric number is CD190022. Today I'm going to present about polygon of force, topic 2. My part is data and calculation. For test 1, we use 4 codes and get 4 angles. For test 2, we add 1 more codes, that is W5, and get these shapes of lines. From this shape and data, we can use it to transform the shapes to polygon shapes. From the polygon shape, we can get the length of each line to use in calculation. From this data and shape, we transform to polygon shape so we can use the length to calculate the weight of W1, W2, W3, W4 and W5 weight using scale ratio calculation. So this is the polygon shapes we transform to. For test 1, we got 4 points, that is A is 70.5 degree, B is 102.5 degree, C is 69 degree and D is 118 degree. For test B, we add 1 more codes, that is total is 5 code and get 5 angles. At A point we got 134.5 degree, B is 85 degree, C is 81 degree and D is 131 degree, and lastly is E 108.5 degree. So after we collect the data, we get the length of CD, DA, AD and EA in cm. For CD, we got 4 cm, DA is 4.6 cm, AD is 2.7 cm, EA is 2.2 cm. For the calculation, we use the scales of 2 cm represent 1 Newton. For test A, we calculate the CD represent W3. CD is 4 cm divided by W3 equal to the scales 2 cm divided by 1 Newton. So W3 we got 2 Newton. Length of DA represent W4. DA is 4.6 cm divided by W4 equal to 2 cm divided by 1 Newton. W4 we get 2.3 Newton. For test B, we use the same scales. The length of DE represent W4. DE is 2.7 cm divided by W4 equal to scales 2 cm divided by 1 Newton. So W4 we get 1.3 Newton. After round off, we get 1.4 Newton. For EA represent W5. EA is 2.2 cm divided by W5 equal to scales 2 cm divided by 1 Newton. W5 we get 1.1 Newton. That's all for
Everyone,
me.
today I would like to explain about discussion part. Okay, first question was, interpret the length of CD, DA, DE, EA in terms of magnitude of the force vector in Newton. Give your comment regarding the result. Okay, first of all, the actual magnitude for CD was 2 Newton. For DA is 2.3 Newton. For DE, 1.35 Newton. And EA is 1.10 Newton. And the obtained magnitude for CD was 2.63 Newton. For DA, 1.78 Newton. For DE, 1.50 Newton. And EA, 1.13 Newton. Okay, the comment, there is a slightly difference between the actual magnitude and the obtained magnitude. This is because the frictional force between the cord and the pulley. As a result, the origin of the equilibrium cannot be determined accurately, which affecting the coordinate direction angle. Therefore, the results obtained are slightly different. And second question was, from the result, discuss the method of using the polygon of force for 4 or more forces in equilibrium at a point. Say how many unknown forces can be found. Keep the following points in mind. What must be known about all the force before the space diagram be drawn? How many of the force lines were not marked off in force diagram? What do you notice about the arrows showing in the direction of forces in the force diagram? And finally, can we find the direction of forces by this method if all other data are given? So the answer is, by applying the polygon of forces, we can find 2 unknown forces, which is also the last 2 lines of the diagram, which is force diagram. Before we draw the space diagram, we should know all the coordinate direction angle of each forces and also their direction. After knowing it, we link all the forces lines together to form a closed polygon. At last, by knowing all the data, we can find the direction of force by this method. And last question was, what are the difference between the triangle of forces with the polygon of forces? Okay, first difference, which is, for triangle forces involve 3 force vectors, while for polygon forces involve 4 or more force vectors. For triangle of forces involve 1 unknown, while for polygon of forces involve 2 unknown. Triangle of forces determined using vector analysis and trigonometry law, while for polygon force is determined by only vector analysis. For triangle of forces only can be drawn as a triangle, while for polygon of forces can be polygon with 4 or more sides. That's all.
My name is Sivanesan. My metric number is CD190170. Today I would like to present about conclusions. Method of the polygon of forces can be used to determine the unknown forces in a system when 4 and more forces are in equilibrium at a point. Although in the end the results obtained have deviations from the actual one, but it is due to the error in assumptions where the frictional force acting between the cords and pulley is 0. Thank you.
Recommendation: we should take the value few times and get the average value to avoid the parallax error, and our eyes must be parallel to the scale when take calculations. We should use more accurate and greater quality of digital measurements to improve the accuracy of the result. Thank you.